Hello, fifth graders. So the past few days we have been modeling how to divide, a unit fraction by a whole number and a whole number by a unit fraction. And throughout our time with modeling, hopefully you've picked up on some little patterns and some little tricks that you've noticed. Now, yes, we can model, but also you may have realize that there's a little trick almost or pattern that you're seeing when you're dividing these whole numbers by fractions and fractions by whole numbers. So we're going to talk about that pattern and that trick today in our lesson. So the problem says Sam has 1/3 of a piece of cake. He decides to share the cake between him and his 4 friends. How much cake does each person get? So, okay, we want to write it as a division problem. So remember, we set up our division problem. Whatever we are sharing goes first in the dividend. So what are we sharing? What are we dividing? We're sharing 1/3 between Sam and his 4 friends. So a total of 5 people. So yesterday's lesson, we talked about how to model this. Okay, represent 1/3 vertically. And then divided by 5 wholes, split it into 5 equal sections, okay? And our answer would be 1 out of 15, okay? Or 1/15. And again, you may have realized that, wait a second, that anytime we divide a fraction by a whole number, okay, a unit fraction by a whole number, the denominator and the whole number, if they multiply together, become the denominator of our unit fraction, or of our answer, okay? So we're going to explore more about that pattern today. So let's look at this problem again. We're going to rewrite it. 1/3 divided by 5, we said, okay? But when we are writing this to do our problem, we are going to write that 5 just like we would when we would multiply as a fraction. So we're going to put that 5 over a what? We're going to put the 5 over a 1, okay? So to get our answer, okay, this is what you are going to do. This is a little division fractions trick to get you by, okay? And it's called keep, change, flip, okay? So what that means is that whatever is first, so in this case, the fraction is first, you're going to keep the fraction the same, okay? So that's the first step. Then, if you are dividing, you're going to change the division to a multiplication sign. And then flip means that we are going to flip the numerator and denominator of the second fraction. Okay, and I'm going to talk more about what that flipping means. So flipping the fraction means finding its reciprocal. And that's a fancy word for just the opposite numerator and denominator. So for example, 1/4, the reciprocal of 1/4 is 4 over 1. Okay, and they are not equal. 1/4 is not the same as 4 over 1. They are called reciprocals. The reciprocal of 5, if we put that over a 1, is 1/5. And the numerator and denominator just switch. So let's look at these examples over here. 7, which is the same thing as 7 over 1. What is the reciprocal of 7 over 1? Well, flip-flop the numerator and denominator, it would be 1/7. What down here is the reciprocal of 1/8? Well, again, flip the numerator and denominator, and it's 8 over 1. So all that is, when it says flip, that means find the reciprocal. And that's a fancy, fancy word for just flipping the numerator and denominator. So the reciprocal of 5 over 1, then, is 1/5. And all we do now is multiply cross. So 1 times 1 is 1. 3 times 5 is 15. And hey, look, we get the same answer. Okay, so yes, we can model it, and I wanted to show you the modeling first, but we can also use this keep, change, flip, or abbreviation for that. People say KCF, okay, Kentucky Chicken Fried, all right, and that stands for keep, change, flip. So we're going to do a few more examples using keep, change, flip. So it says Kelly has 4 pounds of trail mix. How many half-pound portions can she make from the 4-pound bag? So the biggest thing with division problems, boys and girls, is that you need to make sure that you have the correct dividend and the correct divisor, because you will get a totally different problem if you flip-flop the dividend and divisor. Because remember, 4 divided by 2 is not the same thing as 2 divided by 4. You cannot flip-flop division, okay? They are not commutative. So, again, whatever goes in this first spot is what is being shared, what is being split. So what would you say? Look at this problem. What is being shared? Well, 4 pounds of trail mix are being shared, okay? And you're seeing how many half-pound portions are there in it. So 4 is being divided by 1/2. So we're going to write it in this space. Now again, the 4 we want to make over a 1 divided by half. So we go through keep, change, flip. Again, I'm going to recommend that anytime you do keep, change, flip, you rewrite the problem again. Okay, so keep the 4 over 1, change the division to multiplication, and flip-flop or find the reciprocal of half, which is 2 over 1. So now we multiply across. 4 times 2 is 8. 1 times 1 is 1. So our answer is 8 over 1, or 8 half-pound portions. So in a 4-pound bag, you can get 8 little half-pound portions of trail mix. Again, we could have modeled that as well by representing 4 holes, splitting each hole into half, and counting 1, 2, 3, 4, 5, 6, 7, 8. Okay, I don't like to teach you just keep, change, flip in the very beginning, because I like you to kind of understand and notice the pattern before we even talk about keep, change, flip. And I think a lot of you did kind of notice a little pattern, which is awesome. All right, so let's look at another example. This one, it says 1/4 of a piece of pie split between Hope and her 2 friends. So again, what is being shared? Well, what's being shared is the 1/4 piece of pie. So 1/4 goes first in our division problem, and the pie is being divided among how many people? Well, don't get confused by just 2 friends. It's Hope and her 2 friends. So 3 total people, but we want to write it like a fraction, so it will be 3 over 1. Now, again, we can model this, splitting it into fourths, and then 3 horizontally, okay? Or we can keep, change, flip. So keep the 1/4, change the division to multiplication, and flip or find the reciprocal of 3 over 1, which is 1/3. So our final answer is 1/12. So 1/4 of a piece of pie split between Hope and her 2 friends. They each get 1/12 of pie, which makes sense because you are starting with 1/4 and then breaking it into smaller pieces. Let's look at this last one. It says Chloe has 7 gallons of ice cream. She wants to give all of her friends 1/3 gallon portions. How many 1/3 gallon portions are there in 7 gallons? So again, what are we starting with? What are we splitting? We're splitting 7 gallons. So again, we want to write it like a fraction, so it will be 7 over 1. And then we're splitting those 7 gallons. We're seeing how many thirds can we get out of 7. So 7 divided by 1/3. So again, keep the 7 over 1. Always keep what's first, no matter what. Change the division to multiplication. And flip or find the reciprocal of 1/3, which is 3 over 1. So 7 over 1 times 3 over 1 is 21 over 1, or just 21. So in 7 gallons of ice cream, there are 21 1/3 gallon portions. All right. So what you guys are going to do, I want you to complete a little Google slide that has you practicing keep, change, flip. Okay. And again, our models are still useful. It's important to understand what is actually happening with our division and our fractions. I don't like to just tell you to keep, change, flip in the beginning because I want you to understand what is actually happening. So that's why I talked about those models. So you can still use the models if you would like. But again, keep, change, flip is a pretty straightforward way when you are, and we use it only when we are dividing with fractions. If we're just regular dividing, okay, you don't use it. If we're multiplying fractions, you don't use it. We only use it when we're dividing and we're dealing with fractions. All right, so complete that Google slide. If you do have any questions, please let me know. And I hope you guys have a wonderful day. Bye.